Welcome back on my channel. My name is Dr. Karl Werner Ulrich from Germany and I'm the creator of rooExtend. In the internet you find me with my initials Dr. CWO. Today I'd like to show you something that you don't know probably regarding the rooExtend. We have a Roon extension that's called rooPlay, and with this Roon extension you can stream different things to Roon. So you also can stream your turntable if you have an ADC that digitizes the incoming signal. And with that there is a chance, if you have such a little USB memory stick, to plug it in to your rooExtend, and with such a test record, the name is CA-TRS 1007. You can make a measurement of your phono chain and see if your pickup is fine or if something gets wrong if you play back your LPs. So how is it possible to check the quality of the playback chain for phono? On this test record, the CA-TRS 1007, there are two sinus sweeps at the beginning of the LP. These sinus sweeps are transported to the ADC. I use a RME ADA24, but you can use any other ADC that has a USB connection. Then the signal got transported to the rooExtend box. I have a Raspberry Pi here, and if I plug this USB stick in the box, the signal from the turntable will be recorded on the USB stick as a FLAC file. That is part of the technology of rooPlay. When you go to your Roon and to the settings extensions, you see here a line that you can plug in a USB stick in rooExtend, and it will record the audio. And this I will do now. And then we start recording. The LP is on the turntable. The needle is not yet dropped. And we can now start recording the LP. What has to be done? We go to the settings of rooPlay and we select the audio interface, the LP symbol. For me here I use a 96,000 kilohertz sample frequency and the analog input for the turntable. If I press save, you will see here the LP show up and the blue light coming up. Now I drop the needle and start a timer on my Apple Watch for 3 minutes. And we can now a bit listen to what we will hear. You heard the needle drop. I go up with the volume a bit. So this is the 1 kilohertz signal at the beginning, and that stops after some seconds, and then the sinus sweep starts. You see it starts at low frequencies and goes up and up and up to 20 kilohertz, and after that we will hear another sinus sweep and for the right channel, and again the sweep, and after 3 minutes we're gone. I will stop the recording and we have a file that we can continue to process on the PC. Okay, 3 minutes are over. I stop the playback here, and you can see that now the post-processing of the recorded audio had started, and this takes some time. And if it's finished, you will see again this is the line you already know. And now I can unplug the USB stick, and here our recorded measurement information is on now. Now I'm here in my study, and I like to show you the post-processing of the recorded audio. For the post-processing we need two URLs. I wrote them down here so you can read. I hope you can read. And the first one is a FLAC to WAV converter, and the second one is a program that brings us up the measurement curves. And so this is the FLAC converter, FLAC to WAV, and this is the measurement program. So you see my screen now, and with the two open browser windows for the two different applications. The first is the FLAC to WAV converter, and the second one is SJPlot. This is the application that creates the image at the end. I also opened a window for my SD card. We see the recording here, and I also opened a window where the downloads go in. You will see why we did this. So starting, we have to customize the converter program that it can handle 24 bits, because our FLAC file is a 96 kilohertz with 24 bits. And we also want to get a PCM with 24 bits. To start the processing, I grab this recorded file and drag it to the converter. He says, hey, I'm ready. The size of the file, you can select where it has to go. Wave is already selected, so I press convert, and he first loads the file up to the server. That takes some time, and if it's got processed, you can press download here, and then the file will be grabbed from the server, the WAV file, and you will see it in the download area here. Funny enough, the extension is not WAV, but it is SY8. I don't know why, and we have to change this to WAV. Yes, I want to change this. This is the first step. Now we have a WAV file. And this WAV file we can drag to the SJPlot application. Here below you see that it got accepted with a green check mark. And I already have filled here some information that goes on the final image that he created for the measurement, the author that I recorded with our IAA. I used the TRS 1007 test record and some more information about my equipment. You can select different plot styles. I select the dual y-axis because then anything goes in one diagram, and that's easy. So I press the analyze button. It will take some seconds. Well, on a modern computer this is done quite quickly. So if you go up here, you have this nice image that I will increase a bit so you can better see it in the video. So here we go. Okay, what do we see? At the outside of the image, we saw the things I entered in the mask, which pickup I used, and what equipment I used, and what my name is, and so on. Let's take a look at the solid lines first. The red and blue line up here is the frequency response of my Shure V15. It's quite nice. I can adjust maybe this a bit. Here the red line, shifting it a bit up with an equalizer in my RME amplifier, but that's not the point. That's not so important. So let's next take a look at the dash pointed lines, the red and the blue. This is the crosstalk. So crosstalk, what is this? It is how much you hear from one channel in the other speaker. And the red and the blue curves, they should be close as possible. And you can adjust it with the azimuth at your tone arm. So rotating the tone arm and doing multiple measurements, you can bring the red and the blue line here as close as possible together. With my tone arm, it's a bit complicated because it has a screw that fixes this, and if I open it and rotate a bit the tone arm, then I get very big very big differences in this curve. So this, what I got here, is the best I can adjust. Maybe you have a better tone arm and can do better here, but not me. What else can we see? We can see the second harmonic and the third harmonic. The second harmonic goes at high frequencies up to minus 20 dB. That's fine. That's how it should be. And I don't know any cartridge that delivers better management. Going down here, you see the distortion gets in the audible range is much deeper. Here around 1 kilohertz, we're below 40 dB. That's fine for both channels, blue and the orange. The distortion measurement goes up to 20 kilohertz here because I recorded with 96,000 kilohertz, so 22 is the maximum I can get here for the second order harmonics, and the third order harmonics should be below what it is, should be below the second order, because this is not so nice to listen to. So best you have a second order harmonic that sounds best. Well, this picture can be downloaded. Here you also can copy it to the clipboard and do with the picture whatever you like. So this is an overall view of your needle, your cartridge, and your preamplifier. The parameters of the ADC are not very important here because the Phono Chain and the cartridge are both have much more distortions than an ADC. So you can use an ADC you like to make these measurements. It helped me a bit that I see how I can adjust the equalizer for my cartridge, and it helped me to adjust the tone arm azimuth with the crossover measurement. So maybe it also helps you. In the follow-up, I will show you some a slide with some URLs that where you can go to get support or discuss with other people that had done some measurements. Before I give you the URLs for the Audio Science Review forum, I will give you some hints if you get an error. in the creation process of the image. If you get such an error, you can plug the WAV file into the Audacity program, and it should look like this. Then it works. The recording consists of a pilot tone, the 1 kHz tone here, and please check if it's within the first 30 seconds. So it must be within here to be recognized. If you drop the needle too late, it may come too late and then it's not recognized. Another issue may be if you record it too low, with a too low volume. So the pilot tone should be about 0.5. Then it's okay, then it will be recognized. So please, if you get an issue with the recording, open Audacity and check the file. Maybe you have to redo the recording. So where to find the information about the script that generates the curves? Open your Google in the browser and enter Phono Cartridge Response Measurement Script. Doing so, you get to the Audio Science Review and follow this link up here. And you're in the forum for the Phono Cartridge Response Measurement Script. This is the script that you use, this app that creates the images with the curves. And there's also a link here to the measurement library thread, because here a lot of people they posted their own measurements. If you scroll down here, something is explained, and you see the responses of different cartridges, and so you can get an idea how well your own cartridge works. So this is just for information. You can get in there and scroll, or you get to the script if you like to work to know how the script works. Anything is explained here. The creator is SJP, and he's also available here, so if you have questions you can ask for further support. So thanks for watching my video, and hope you enjoyed what you learned, and hope you will have fun measuring your phono cartridge and your preamplifier and get best out of your phono experience.